Hello and welcome back. Today we're going to continue our science lessons, still thinking about materials and their property. But actually the aim of this lesson is to think about how we might recognize and write a scientific report. Now this is really important because the scientific reports allow other people who might not have necessarily done the experiment understand what you did, can see your results and understand what you believe to be the outcome of that investigation is. Not only that, they should be able to follow the method that you've included to undertake the same investigations and repeat the results that you've got. So, can I? Can I explain the aim of an investigation? Can I give specific instructions on how to complete the investigation? And can I clearly show results to make a conclusion? So as you move through TLAP and on to secondary school, you are increasingly becoming scientists in the way you think and what your approach to science is. The way in which you carry out investigations becomes more scientific, and therefore you need to accompany that with writing down your scientific understanding and investigations in the proper way, in a proper written scientific report. Every scientist, you write their reports in a particular way, or in at least the same idea. Even when you go to university, and it's not necessarily a complete scientific report, it might be a psychological report of an investigation. But any sort of investigation, you write in a very similar way. You write what your aim is, you write what your prediction is, you write how you went about doing it and why you were doing it. And then you talk about your results and conclude or discuss at the end what you found out. And that's what we're going to think about. So, first off, is the aim, or sometimes called the question. And what the aim is what you're trying to find out. What question are you trying to answer? What is the problem you're trying to find a solution to or an answer to? So, an example might be to investigate what is the best size for a parachute canopy, something we did in forces. And what you're trying to do is design an investigation to answer that question. Your next part is your prediction. You think about what you think will happen or what the expected results are, not just off the top of your head, but using some scientific understanding in order to get there. So I think the biggest canopy would fall the slowest. You could make this prediction even better by saying why. I think the biggest canopy will fall the slowest as it will cause more air resistance. Then you're thinking about your apparatus or equipment. And this is telling somebody exactly what they would need in order to carry out the investigation themselves. Before they even look at the method, they need to know what they need to gather, the apparatus they need or the equipment, in order to follow your results and get accurate results like yours. Quite often, this includes a diagram. Remember, diagrams aren't sketches, they are particularly different, they are more scientific, they are labeled specifically as to what you want them to do and what you're trying to show. And then you'd have a list of whatever your apparatus might be, so bin liners and 5 of them, string, tape, a weight, and a stopwatch. Your method. This explains exactly what you've done in detail so that somebody else could follow your method and come up with the same results, or at least come up do it the same way. Within your method, you're also addressing any issues such as how are you keeping it a fair test? What variables are you keeping the same? Or what variables you're changing? Because that's important. By stating that in your method, you're letting other people know that you've thought about possible problems that may come up and you're narrowing it down. So you're only trying to answer the one question you ask in your aim rather than including lots of other ones. So for example, first measure and cut 5 squares from a bin liner. Each square should be a different size, and then it has a size. Next, using tape, attach 30 centimeters of string to each corner of the bin liner. Note we're using adverbials to tell order here, first and next. Once complete, again, bring the 4 strings together on each parachute and tie a knot as close to the end as possible. And this should remind you of writing instructions. It is very much give enough detail that the person can follow exactly what they need to do. For testing, hook the peg weight onto each parachute in turn. Make sure they drop all from the same height and the same weight. This is taking into account any other variables that you don't want to test. You only want to test the size, not how far they're falling or whatever weight they're having to be using. Use a stopwatch and time the parachute drop. For the test, we use the same material for our parachutes, the same length of string and the same weight. We also drop from the same point. The only variable we change is the size of the canopy, making the test fair. And that's your fair test wrap up. So your results. As you carry out your tests, you're going to keep a record of the results you found, normally in a table to begin with, like this. You might then, after you've got your table, put that into a graph. And the reason you might use a graph is because it is more visual and easier to see any patterns there happens to be. So you can understand where there might be a pattern or where there might be an anomaly in your results, one that stands out as strange, that doesn't follow the pattern, and then you can make a judgment as to why that might be the case. If you were to draw this out, you'd get to the 50 and you'd go, wait, this 50 dropped a lot quicker than it should do if we're following the same pattern. Why might that be? And in your conclusion, you can think about why that might be and explain those weird results that you might have. What the aim of the conclusion is to explain what you found out from your experiment. Link it back to your aim. Does it answer your aim? You can write down what happened, but you also must explain it in a scientific way as to why you think that was the case. So, for example, in testing, the 40 centimeter canopy fell the slowest. The largest canopy, 50 centimeters, was unable to open in time. I believe that the best size for the parachute canopy depends on the weight you attach. So they've given more information. Why they think it might depend on the weight they attach is because if it was a larger weight, might have more time for the larger parachute to open up and therefore be more effective rather than dropping quicker. So, your task. What I want you to do is choose from this list of investigations and write it up. So the investigations you can choose from is, how should I fold a piece of paper to throw it to the furthest? Second choice is, what liquid is best to clean a penny? And the third is, what shape of pasta is the strongest? Now, choose the one that you can easily do in your house with what you have available to you, or the one you find most interesting. Remember, if you're throwing the paper, don't throw it at somebody. If you're cleaning the pennies, careful what cleaning products you're using. And if you're testing pasta, don't steal anyone else's dinner. So, your task. You've got your ideas down the side, and what you need to include in your scientific report is an aim, a prediction, your apparatus or equipment, alongside a diagram, your method, results, and conclusion. Go back through as you write your investigation. Go back through this video. Pause at each part that you come to. Use the examples to try and help you and the explanation to help you write that part. Good luck, and I'll see you in the next video. Goodbye.